let's talk about on-site oil analysis for marine applications, or more appropriately, onboard applications. We talk about marine markets. We talk about really three major areas: the merchant marine, naval forces, and then cruise lines. All of them essentially are on the sea. Um, it's important to talk about them because it is a very large market who really do need to have on-site oil analysis at all times. 90% of global trade is by sea. There's about 70,000 vessels out there transporting goods around the world. Naval forces are also widely use oil analysis. They're continuing to develop and project power and influence for their various countries. And then we have, of course, the cruise line or entertainment industry, which is a very fast growing segment of the marine market with high profitability. And so reliability is critical to those areas. In any marine application, you've essentially got a prime mover, which is the main engine. But you have other key lubricated assets on board as well. You have thruster hydraulics. You always have to have backup generation for power. These are often known in the naval industry as SSDGs, or ship service diesel generators. You have gear reducers. You've got compressors for air. Essentially, what you have is a floating power plant. And so you have many, many different lubricated assets. There's a variety of different choices because in this world you have different types of engine design, you have different types of fuel that has been used, you have different types of fluids that are used, and as a result of that, we have to monitor those on a regular basis. What are the major challenges that are facing fleet managers who are responsible for marine applications? Well, there's some major challenges out there. I would say there are three most important ones. Number one, there is an overcapacity in shipping. As a result of that, there are more vessels out there than there is goods. And as a result of that, merchant lines are managing different approaches in terms of trying to reduce cost. Some of those effects have a negative effect on the reliability of the equipment and has an effect on why you should be doing on-site oil analysis, particularly when it comes to things like slow steaming issues. A major issue coming up that's going to affect the industry worldwide is the sulfur regulation that's about to kick in 2020. That has a major effect where all the fuels that are typically heavy fuel oils, high sulfurous fuels, are going to go from 3.5% soot down to 0.5%. And as a result of that requirement, there's got to be some significant investment made in the marine industry in terms of how they're going to manage with that. Combined with that, there is a lot of issues regarding fuel quality assurance. How do you best manage that on board, because it has such an effect on reliability? Related to that, there's already existing sulfur emission control areas around Europe, in the US, in certain areas of China. And so as a result of that, ships right now have to switch from high sulfur fuel to low sulfur fuel when they go into port. And when you switch, you also have to match the engine lubricant, especially on two-stroke engines, to go from a high base number to a low base number. And that is an issue. Thirdly, there is the US VGP, or Vessel General Permit Compliance, that was issued in 2013. And that essentially means that any vessel that is longer than 25 meters or 79 feet must have some compliance, whereby any oils that are come in contact with water have to be able to be biodegradable, leave no sheen. And so as a result of that, there is more of a requirement for the rotating equipment to have EAL, or environmentally aware type of lubricants, or biodegradable. So these major issues are really affecting the industry. It's making it a lot more complex than it ever has been, and onboard monitoring is essential to navigate your way through these processes. We mentioned earlier the different types of engines and fuels, and as we said, two-stroke power is the most common that's in cargo ships. Those engines usually are built with the ship. They have a long, reliable life. They're very easy to manage overall. But on the very large engines, it's essentially you've got two different lubrication systems. You have a once-through cylinder lubrication system where you have the compression occurring. The BN base number of the oil is absolutely critical because it is the first response, and it is a neutralizer for those sulfuric acids that are generated when you burn high sulfur fuel. You also have system oil, which is essentially separated from the cylinder area, and it's much like a traditional four-stroke engine oil application. So we always worry about that. You also have four-stroke applications that are running high sulfurous fuels. If that's the case, you need something like a TPEO or trunk piston engine oil, which is got a right additive package to be able to manage those high sulfurous fuels. Or you can have regular four-stroke lower base number. As you can imagine, with the industry switching from a high sulfur to a low, everybody is going to be moving more towards a more conventional system oil or TPEO type of environment. In the case of the VGP permit requirements, these EAL or biodegradable fluids we mentioned earlier is requiring switch out for many of your rotating equipment, such as your thrusters and hydraulic systems that come in contact with water. And you have to be able to manage these water-insoluble or water-soluble PAGs or EAL-style vegetable oil-based lubricants that are present. They don't have the same life if you don't manage them carefully. And of course, in certain gearbox applications, the drive is to go towards higher synthetic, long-life applications. More expensive at in the front end, but have much long life, but you have to monitor them very carefully. So let's talk about the type of tests that you use for marine condition monitoring applications. Predominantly items that would be used on board, and what the meaning is for. So the major engines we talked about earlier are two-stroke and four-stroke, and it's important to be able to separate those out because there are distinct differences and requirements. So in the case of the two-stroke, in the case of the cylinder oil that's been once through lubrication to the cylinders, the major worry about that is base number and viscosity. That's all about getting the fluid to the right area of the cylinder and to make sure that there's enough alkaline reserve there to neutralize any acids that are being produced. Base number in those ranges can be anywhere from 40 up to 200 base numbers, so it's a very high range. And you should always be looking at those on a continuous basis, both on the incoming lubricant, if it's coming right out of the bunker, or if you have a blending on board system where you have added system oil or waste engine oil and added an additive package to bring up the base number, you want to monitor that before it sprays onto the cylinders. Once it comes off the cylinders and it drips out on the drain residual drain, you want to be keeping an eye on that. The base number, if it changes dramatically, indicates the level of sulfurous fuels and what's going on and the flow rates. Another test to check is the scrape down oil, and so that's essentially the residual material. And what's also looked at there is ferrous content, because that's indicative of the amount of corrosive wear that's also produced if you do not have the correct alkaline reserve, or you do not have the correct rate of treat rate to the cylinders. Ferrous density is important. It looks at the large debris that might be popped out of the cylinder wall if you have excessive wear. However, it is not sufficient. You also need to be able to look at the corrosive wear, and in those cases we recommend elemental spectroscopy, especially for the corrosive. The two results together will give you a total iron content. In the case of the system oil, which is separate from the cylinder oil, the base number there is required. Also ferrous density to look for any abnormal wear, viscosity at 40 to 100. Remember, this is long life oil. It's going to be kept in the system. Water content, of course, is critical in this situation, even though it can accommodate a lot of water. You need to be controlling it. And of course, elemental spectroscopy to be able to look at the wear elements, contaminants, and additive package. In the case of regular four-stroke engine oil, basic test we always recommend is base number, also ferrous density and viscosity. Those key tests are very important. They give you a first check. They can be done easily on board. In addition to that, we always recommend you do the water content. as well as the elemental spectroscopy. With the sulfur cap that we mentioned earlier, you're going to see more and more engines that are powered by natural gas or LPG or propane-based ships. If you have those situations, you're going to probably see more of a requirement for total acid number, very similar to land-based natural gas compressors where 10 and TBN is required. Same thing would happen on the ships. So you'd look for the 10 result in those cases. In the case of your rotating equipment, particularly your thruster hydraulic situations, where you have mineral or EAL fluids, we recommend that you do ferrous density, viscosity. You want to check your water content. And a good note about these EAL type fluids is that they have a very high capability for water. In some cases, you can have 4, 5, 6% water. That's up to 60,000 ppm of water, and it's not considered to be necessarily a problem for the application because it holds it in solution. You need to be able to measure that and be able to control it. Total acid number is also important. It indicates the level of oxidation if there's any breakdown or hydrolysis occurring. Elemental spectroscopy to see if there's any wear additives and contaminants. And particle count is important to look at the overall debris as well as the how well the filters are doing. In the case of gear systems, we recommend that you do ferrous density. It's a critical point for any large ferrous wear. Viscosity, of course, because it's critical for lube film strength. Water content, total acid number to look at the long life and oxidation issues, elemental spectroscopy. And we also suggest particle count, particularly for pressurized gearboxes or transmission systems. Because you may have filters, so you can look at the filter efficiency, but also it's important to see if you have shape morphology too, because you can look at the size and the shape of the material to indicate if there's any abnormal wear present. Compressor systems, very similar to gear systems, where you're looking at your ferrous density, your viscosity, your water content, your acid number, and your elemental spectroscopy. Particle count is optional depending on the type of compressor that's there. In all these situations, for onboard applications, we definitely recommend you investigate the Mini-Lab series because that has the right packages. It's a mix and match capability that's got the right sensitivities, and also the TrueView 360 helps you to manage your data that you analyze on board and be able to issue reports immediately. We also suggest, of course, for the merchant fleet, where you are concerned with this sulfur cap situation, that you investigate something for fuel quality assurance on board, particularly when you look at the sulfur.